So in each of these triangles, we want to find the angle A in degrees rounded to 2 decimal places. So as we look at the first triangle, the secret is to decide how the sides are related to the angle and then determine the trig function. So if I look at 5, that is opposite angle A, and I see that 9 is the hypotenuse of the triangle. So that leads me to use the sine function, because that is opposite over hypotenuse. So I've got the sine of angle A is opposite, which is 5, over hypotenuse, which is 9. And then I take the inverse sine of both sides so I can find out A. A is the inverse sine of 5/9. Now I'm ready to get some calculator help to find out what that is. And so I need to hit the second or inverse button on the calculator to get the inverse of the sine. And then I'm going to put in 5 divided by 9, parenthesis to finish it, and enter. And it looks like that angle to 2 decimal places is 33.75. So 33.75 degrees. Now as I go to this second triangle right here, I see that this 15 is opposite the angle and the 4 is the other leg that is adjacent. And the trig function that connects opposite and adjacent, tangent of A, is going to be opposite, which is 15, over adjacent, which is 4. So if I want to know the angle A, I'm going to write it down below here. A is going to be the inverse tangent of 15/4, and we'll go ahead and put that in the calculator. So I'm going to do the second so that I can get the inverse, and that's going to be of 15 divided by 4. That looks like that's 75.07 to 2 decimal places, so 75.07 degrees. And then looking at the third triangle, I see I have a leg of the triangle that is adjacent to A, and then I also have the hypotenuse of the triangle. So this one will be the trig function that connects those, which is going to be cosine. So cosine of A is going to be adjacent, which is 7, over hypotenuse, which is 12. So A is going to be the inverse cosine of 7/12. And using the calculator, inverse cosine of 7 divided by 12, and that's going to be 54.31 to 2 decimal places, 54.31 degrees.